Hello, this is the Tepid Coder. In this video I want to talk about transactions in SQLite. But before I get to that, I want to go over some changes I made to my SQLite functions. I stuck them in two files, SQLite_wrapper.cpp and SQLite_wrapper.h. Let's go to the header file first. So essentially this header file is going to have all the same classes that I've defined, the SQLite database, and SQLite statement. Now, all of the definitions of the functions are going to be in the CPP file, except for the definitions of my template functions. Now, something else I've added since then is an exec function. This exec function is just a pass-through for SQLite3 exec. What this does is it takes a query, it prepares it, it runs it with SQLite3 step, and then it finalizes it with SQLite3 finalize all in one call. And if there's any row of data to return, for each row of data that's returned, it'll call this callback function that you provide. It can be nullable, and if it's nullable, it won't try and call it. And you can also pass your own data into each of these row callbacks. So you have some class object or something you want to pass in there to act differently on each row or something to give it some kind of context, you can do that. Anyway, I've also made a function overload for this, which is basically a function that has the same name but different arguments. Or in the class, it can also have a different const qualification. In that case, it could be a valid overload as well. This just lets me call the same function with less arguments if I don't care about the callback function or the user data. Okay, other than that though, it's going to be the exact same functions as before. All the templates exist inside this header, and all the class definitions, declarations exist inside this header as well, whereas the definitions exist inside of the CPP file. So you can see my three templated functions here are going to exist inside this header. Alright, now let's look at the CPP file. And you're going to see it's just going to be the definitions from there. Anything that's not templated, it's going to be in this file, and that's it. So nothing too spectacular to see there. Okay, now let's go to my main file so I can talk about transactions. So what happens in a transaction is when you start to update fields or you try to insert new records, it's going to, by default, automatically do whatever changes you say as soon as you run the query. But if you start a transaction, it's actually going to wait to commit that until you actually say commit. So you can say begin transaction with begin, semicolon, and you can commit the transaction when you're done with commit, semicolon. And if something goes wrong, like say you're reading from a socket over the internet, getting some data, the socket could randomly close unexpectedly or something. And you're not going to want to insert bad data or like partial data into the database. You might want to roll back the transaction. Or maybe you're reading from a file and parsing something, and there's like a syntax error inside of what you're parsing, and you can't parse it properly. So rather than inserting some bad data or incomplete data, you decide to just roll back the transaction and not alter the database at all. So that's what this is for. So what I do in this example here is I'm going to create a shared pointer to a new SQLite database class that loads from this file somedatabase.dat in the same folder. And then I'm going to create a prepared statement, an SQLite statement in my class right here, that's going to create a table called junk that includes a signed 64-bit integer. Now SQLite might not actually store it this way, but I'm labeling it this way because my function, it's a variadic template function in C++, which binds arguments, which are integral, as signed 64-bit integers by default when it detects any kind of integer. And it will use the SQLite3 function, which uploads something as an int64 type in order to store the data. However, even though that's the case, SQLite3 could be storing it in a different way. It just will use that much space and treat it as that type if needed. And when you pull it back out of the database, the type deduction is also going to treat an integer as being an int64t in my template that I made. So it's going to use that function to request that SQLite3 gives you that value as a signed 64-bit integer, even if it wasn't actually stored that way. So I'm just trying to be explicit about that, just because when I stick it in, I'm acting as though it is one, whether or not it is, and when I pull it out, I'm pulling it out as one, even though it may not be stored that way inside the database, right? Okay, anyway, I then run a prepared statement right here, the one I made, in order to create that table if it doesn't already exist. So when you create tables, you can say if not exists, that way you don't get an error when you try to run the query, if it already exists. That's really all that's for. Anyway, after I've created the table, I'm then able to prepare a statement that inserts something into it. Now, I wouldn't be able to actually create this prepared statement and instantiate this class object properly if the table didn't already exist, because when you try to prepare a statement, it's going to see it as a syntax error if the table doesn't exist. So that's why I'm actually creating this inside of the try-catch block. Kind of annoying to have to do that otherwise, but whatever. So all I'm going to do is insert a single value, the number in there, with some templated argument. Okay, so the first thing I do is I call that exec function to begin a transaction. All right, and if that fails, I complain and I bail out. Otherwise, I'm going to insert 100,000 records into the database. And each one is going to have a value that is equal to the current loop iteration, 0 through 99,999. And I'm casting this to an int just to ensure that it is using the proper type when it's doing type deduction. Okay, and then every single time I try to bind arguments, if it fails, I'll execute rollback, and then I'll bail out, which means anything that was inserted previously will not actually be stored in the database. It'll just abandon everything I just tried to do. And every single time I bind something, I then try to step through, which means I'm actually executing the prepared statement and doing the insertion in the database. And if that fails, same thing, I execute a rollback and say give up, don't actually insert any of this that I was just trying to insert, just give up on that, and then bail, right? I put exit 0 here because I'm pretending like this is some kind of real transaction in the middle of an application, not just inside the main function I'm returning from. So returning from here might just bail out of that one function, but maybe it's not actually fatal in that sense. If there was ever a case where exec on rollback failed, it's probably because I'm maybe sharing like a database handle across multiple threads, which is undefined behavior. It creates race conditions. It's not defined that you can do that in the SQLite3 spec. You'd actually have to have multiple open database connections to the same database, one per thread, in order for it to be safe. And I think it does that with file locking or something internally. I'm not exactly sure what the implementation is, but that's how you need to do it. You could also just have a queue that you put your transactions into with the locking mutex, and you could just pull things out in a thread-safe manner. That would also be fine if you want to do that with multiple threads. Anyway, between every transaction, after I do the step and run it, I have to reset so that the next time the loop runs, I can bind a new argument. So I do that. So bind argument, run the query, reset, bind a new argument, run the query, reset, do it 100,000 times. Okay, and at the end, I'm saying rollback. So it's not actually going to put anything in the database. I'm just assuming I don't want the data failing on purpose. So let's actually show that real quick. So if I run this, let's compile first. Main. Okay. Alright, and if I go into my database here, open it, I can show my, I want to show my schema. I'll just type it, I guess. Alright, and I can select count star from the junk table. You can see it exists. There's 0 records because I rolled it back. Now let's try it with a commit now. We'll actually commit the changes, and you'll see that it'll work. Okay. Okay, letting it bind and insert the rows. Okay. Where is it? There it is. Now I can see 100,000 records. If I want, I can say select everything from my junk table, order by ID, descending, limit, let's say 20, last 20 rows. Okay, so you can see it ends with 99,999. I'm only showing the last 20 rows. Anyway, this is pretty useful for a couple of reasons. One, it's a lot safer to do it this way. Like I said, if there's an error, you can avoid putting partial or malformed data into your database. But also, it's faster in a lot of cases to start a transaction, do a bunch of inserts or updates, and then commit it all at once. Otherwise, when you insert things, it has to persist it to the file every single call. So this is doing it all in one call, which should be a lot faster. I'm tempted to do a benchmark on this. Maybe I'll do it in a different episode. But for now, I'm going to leave it at this. If you like this video, give it a thumbs up, and consider subscribing for more content like this. If you have any questions or suggestions or criticisms, I'd love to hear all of that in the comments so I can improve this and make sure that everyone at any level coming into this is able to work with the information that I'm providing, either in this video or other videos I've done. So if I need to do any follow-ups, I will. Anyway, thanks for watching, guys. Have a great day, and I will catch you in the next one.